Now in the question 6 type of question, we want to simplify the following expression, right? So let's go ahead and do that. Now here, when we simplify the following expression, there's always methods that you can apply, right? Now I have steps that I always do to basically speed up the process, right? Now here, the first thing that you always do is you always need to first look at the negative angles, right? Now negative angles will be angles that will have a negative, right? Like for example, x minus 180. So this is a negative angle. Why? Because here we know that x is assumed to be an angle that is between 0 and 90, or if you didn't know, x or theta is always an angle that is between 0 and 90. So if you have a value that is between 0 and 90, let's say 30, then you minus that by 180, you get a solution that is going to be negative, right? Hence we call them negative angles. So now here, what do we do when we see a negative angle? So when we see a negative angle, you add 360, right? So that's the first thing that I'm going to do here when I'm simplifying here. I'm going to have my 180 minus x, then here on my 10x minus 180, I'll add my 360 like that, and then I'll just keep the others as they are, because when I'm adding that 360, or when I'm starting with the negative angles, I'm going to be forced to end up with only angles that are reductions and angles that are already been reduced. So that's what I'm trying to achieve here, right? So here, then I know minus 180 plus 360 is 180. So this will then result into having plus 180, because it's going to be positive, which will then be 180 plus x. And then this then means now here I have sine 180 minus x times 10, 180 plus x times cos 360 plus x over sine squared 180 plus x plus sine squared 90 minus x. All right, then now here I'm done with the negative angles. So what did I do here? This was negative angles, and then now here I'm going to apply what? I'm going to apply my reductions. Now reductions, also please understand that we only have 4 reductions, right? We have 180, let me start here, 360 plus theta, so I'll say 360 plus an angle theta, and then we have 180 minus theta, we have 180 plus theta, then we have 360 minus theta. So from there, this is the only thing that we're going to first apply, right? Now we have 180 minus theta, we know it's in the second quadrant, and we can see sine is positive, so this means when I have sine x times, then here we have 180 plus, so this was that, then now we have 180 plus x, which is on the third quadrant, and 10 is positive there, so when I have 10x times, then now 360 plus x is in the first quadrant, and cos is what is positive there, so when I have cos x over, now here we have a sine squared of a reduction. So a sine squared of any reduction is always that a trig ratio that is squared, right? It is always going to be it's always going to be positive, basically, right? So this means here, if you have a sine squared 180 plus x, even though 180 plus x is in the third quadrant and sine is negative there, but because of that was squared, this then means now that this will automatically be sine squared x, which is positive, right? And then now here, this is not a reduction, this is a cofunction, so we're gonna keep it like that first, and then we're gonna talk about that after that one. All right, so here what did we do? We applied reductions. All right, and then now here, now we're gonna go into the cofunction. So first of all, cofunctions, so we're gonna have sine x first times 10x times cos x over sine squared x plus, now here our cofunction is sine 90 minus x, right? So it is sine 90 minus x, but it is squared, so I'm going to put the square outside. Now 90 minus x belongs in the first quadrant, right? These are cofunctions, so cofunctions will be something in this manner. Let me just draw it here. I'm trying to find space. Okay, let me just squeeze it there and put it there, right? So cofunctions are 90 plus theta and 90 minus theta. So the idea here is that when you're having sine, cos, or tan containing 90 plus theta or 90 minus theta, then it means it's going to change, right, the trig ratio. So it's mainly focusing on sine and cos. So sine becomes cos and cos becomes sine, and depending on the quadrant that it was located, and that's when you get the negatives and the positives, right? So here 90 minus x is in the first quadrant, but sine is positive there, but then this means sine becomes cos, right? So we're going to have this times 10x times cos x over sine squared x, plus then this is going to be basically cos x, but then because of we square it, then this will be cos squared x, right? Now we're going to simplify from here. So here, what did we do? We said cofunctions. All right, then now from here basically we're going to simplify, right? Now I can see here that sine squared x plus cos squared x is equal to 1, and then I can see that 10x is sine x over cos x. So therefore I'm going to say sine x times sine x over cos x times cos x. So that's the numerator part over, and then the denominator part is 1, right? So it's going to be over 1. And then as you can see here, this cancels with that, and then I'm going to be left with sine x times sine x over 1, but I'm going to put the over 1. Now sine x by sine x is sine squared x, and that is going to be our final answer. All right, now you see here the step, the way that we applied it. This is basically how you simplify whether you are you have the numbers or you don't have the numbers, right? So let's go ahead and look at the second question. Now the nice thing is the second question has numbers or it has numericals, but then now they want us to simplify this without the use of calculator. Now before I start with this one, I want you to understand this thing here is here to limit you, right, to confuse you. So don't ever look at this, right? If they're saying don't use a calculator, you must definitely use a calculator. Here's why. The reason we're using a calculator is going to help you to understand whether you're doing the right thing or not, right? And also with the special angles, in these days there's a simple way, or there's an easy way to identify whether you press a calculator or not, right? So we can basically bypass the idea of what they see in the solutions, right? And we can basically write our answers in such a way that we didn't use a calculator, whereas we actually use the calculator. All right, so I'm going to show you now in this one in a minute. So let's just go first and look at the question. So it says let's determine the value of that expression, right? Now the first thing that you always do is the minute it becomes numericals like that, you need to press that on your calculator first, right? So the reason why you're pressing it on a calculator, of course, is because you wanted to make it easy for yourself, right? You want to make it easy for you like that. 10 675 and cos 258. So what do I mean when I say I want to make it easy for myself? So I know that when I'm making it easy for myself, I know that the final answer that I need to have at the end should be minus 1 over 2, right? Minus 1 over 2. Then from there I then apply my work, right? Now just like we did earlier, the first thing that we do is we check for negative angles, right? Now as you can see there, we don't have negative angles, so we're going to move straight into reduction, right? Now what are reductions? So reduction, we're looking for angles that are more than 90 here, right? Now angles that are more than 90, I can see 330 is more than 90, 150, 675, and 258, right? But then before I do that, right, before I look at the reduction, remember reduction needs to be between angles that are between 90 and 360. But then here I see that I didn't pick this one. I noticed that I have 675, which is an angle that is above 360, right? Now the first thing is every time when you simplify this, you always need to look at the angles that are negative angles and also that are above 360. And then the idea is that you just simplify minus that by 360 if it is above 360, and then if it is a negative angle, you just add 360. So the first thing that we're going to do then means now that we're going to first keep the cos 330 times 10 150 times sine 12, but then now here on that 675 you just go to your calculator and say 675 minus 360, right? Then you see here you're getting 315, so we're gonna say 10, and then you're just gonna change that value and write it as 315, and then times cos 258, like that, cos 258. Now as you can see, all of them are between 90 and 360. Then you're going to apply the reductions. Now we're going to start with 330. Now 330 is located in quadrant 4. Now what we do is we need to write 330 using the reduction in quadrant 4. If you remember, the reduction date was 360 minus theta. Now you're going to ask yourself, if I have 360 minus, what number can I subtract with, right, on 360 to get 330? And the answer is 30, right, times 10 150 is in the second quadrant, right? Then you're going to ask yourself, second quadrant is 180 minus, right? So 180 minus theta. So you're going to ask yourself, what number can I subtract 180 with to get 150? As you can see, it is 30. And then what about sine 12? Sine 12, you're not doing anything with it because it is already been reduced, so we're going to keep it like that. And then we're going to say over 315. It's in the fourth quadrant, so we know it's going to be 360 minus, so the value to minus 360 with to get 315 is going to be 45 times, and then 258, so it's going to be cos 258 is between 180 and 270, so that's third quadrant, so that is going to be 180 plus. Now what value can I add with 180 to get 258? So that will be 78, right? There we go. Now from here we wrote these numbers, we changed how they were written and then wrote them using the reductions. And now we're going to apply the reductions. Now the reduction goes like this: 360 minus theta, right, is in the fourth quadrant, and then cos theta is positive, so this means you're going to have cos 30. Now theta is going to be 30 times, now 180 minus is in the second quadrant, 180 minus theta, right? Then now 10 is negative there, so you're going to have negative 10 30 times sine 12 over 360 minus again theta is in the fourth quadrant, but 10 is negative there, so you're going to have a negative 10 45, right? And then 180 plus theta is in the third quadrant, but cos is what is negative there, so you're going to have a negative cos 78. Now let's simplify the signs here. So here we have this negative, so remember this was positive, right? This was positive, so basically we just multiplying the signs. Positive times negative is negative, and then negative times positive is negative, so this means it's going to be negative cos 30 times 10 30 times sine 12. And then we do the same thing here. Negative times negative is a positive, so this means in the denominator we're gonna have a positive 1045 times cos 78, right? Now here what do we then do? So after we did this, right, remember that's it's basically how we applied it when we were simplifying earlier. Remember we said negative angles, and then now here we even included angles above 360, right? And then after that we said reduction, right? Reduction. Then now the next thing that we were supposed to do, right, after applying reduction was cofunction. So that's what we're going to do now. Now cofunction in numericals or in numeric trig ratios, that's when we're looking at angles that are not special angles, right? Now special angles we know are basically these angles: 30 30 45 60, right? then non-special angles is 78 and 12. Now what are we going to do with those ones? So basically what we will do is we will take one of these. For example, we're going to take 12 and then we're going to write it using a cofunction, right? So it's either we take 12 and write it as 90 minus 78 while we're keeping 78 like that, or we're taking 78 and we write it as 90 minus 12. Both of these, if you're pressing on the calculator 90 minus 78, you're going to get 12. And then if you're pressing 90 minus 12, you're going to get 78. So we want to have one thing, right? So we'll rather have 90 minus 78 and then change it and then write that into a cofunction which will be 78, right? So that's basically what we're going to do here. I'm going to say cos 30 times tan 30 times, now what are we doing? We're changing 12. We write it as a cofunction, right? So a cofunction 90 minus 78, right? And then we say over, then we say 1045 times, now with this one we're not changing it, we're keeping it. Why are we keeping it? Because when we change that one it will be the same as this one, right? So this will be cos 30 times tan 30. Now 90 minus 30, 90 minus theta, right? 90 minus theta, we know that is a cofunction in the first quadrant, but then sine becomes cos the angle 78, right? Over 1045 times cos 78, and then as you can see here, this cancels with that. Then we have a minus cos 30 times tan 30 over 1045, right? And then from there we can then press our calculator on the special angles. Now the way you press your calculator, you need to be very simple, very careful, right? You need to press each value there. For example, we say cos 30 like that, and then you see we get an answer like that, and then you're gonna write it like that, right? Because remember, we don't want to show them that we press the calculator, so the best way to do it is if we're doing it step by step. Now here we said 1030. Now if you're noticing there, when I pressed 1030, right, I got square root 3 over 3. Now square root 3 over 3 only comes if you press it on a calculator, right? So because of we having this then means what you're going to do is that you're going to change this one into 1 over square root 3, right? Now the only things that you're changing here are only 2, right? Others you just write them as they are. But if you find another answer being square root 2 over 2, this one, it means you need to change it into 1 over square root 2, because this one, it shows that it came from a calculator, but this one, it means no calculator. That's basically what it means, right? So here we have 1030 as square root 3 over 3, but we're gonna write 1 over square root 3 here, right? Over, then now let's press the last one, 1045, 1045, we're getting 1, so that is 1, or you can just write it as 1 over 1, right? And then as you can see here, we left with negative square root 3 for 2 times 1 over square root 3, and this cancels with that, leaving 1 1. Now 1 times 1, so that is going to be minus 1 over 2, and that is your answer, which is what you got earlier there, right? All right, now let's look at the last part, which is the last part is going to be 6.3, which is basically the identities, right? Now here it says we're given the identity and they want to prove the identity, right? Now the first thing is to prove an identity, the way it works is we first need to look at the one that needs to be simplified. Now in this case, as you can see, we can see that it is the left hand side. Now the idea here is that when I'm simplifying this left hand side, my final answer should be the same as the right hand side, right? Now what happens if you don't get that? If you don't get that, then it means you need to take the right hand side and simplify that one also, right? Now if you don't get the same answer as the left hand side that you just simplified, then it means your algebraic expression or your algebraic simplification was wrong, right? So let's first start with this one. So here I'm simplifying here. So the first thing that you always do when you simplify is you always look for sign, the double angle sign, right? So the one double angle sign, you always change that one first while you're keeping the double angle for cos as it is, right? So we're going to change this one into 2 sine alpha times cos alpha minus sine alpha, and then here we're gonna then keep this one like that, right, plus cos 2 alpha, and then over, then here I can see I have a common factor which is sine alpha, and then this is going to be 2 cos alpha minus 1. Now this sine 2 alpha, it helped us to understand what is it that we need here on to change cos, the double angle for cos into, right? Now here, as you can see, this means now if I have the 2 here I have the 2 cos alpha minus 1, right? Then now what I need to do is I need to change this cos 2 alpha to only contain only cos. As you can see here, I can also have cos there, right? So this then means now here what I'm going to do is, in my double angle for cos 2 alpha, I will change this to 2 cos squared alpha minus 1, right, over sine alpha into 2 cos alpha minus 1. And then from here I can see there at the top I have the trinomial. So the trinomial is going to be 2 cos squared alpha plus cos alpha minus 1. So this means I need to factorize that one at the top, while this one I keep it as it is there, right? Now let's factorize that one at the top. So the factors there is going to be 2 cos alpha and cos alpha, which gives us 2 cos squared alpha, and then the factors for 1 is 1 and 1, and then here I'm going to have the positive here and the negative there. So that way I know that if I multiply this with that, I get the 2 cos alpha, and if I multiply this with that, I get a minus cos alpha, and when I sum both together I get a middle term there, which is going to be cos alpha. Alright, and then I'm going to say over, and then here I have my sine alpha into 2 cos alpha minus 1. Then as you can see here, we have this and that cancelling out, and then I'm left with cos alpha plus 1 at the bottom, at the top, while I have sine alpha at the bottom, right? Now as you can see here, this is the same as the right hand side, right? Then now let's go ahead and look on to 6.3.2. Now 6.3.2 says that let's get that. 6.3.2 says for which values of alpha is the identity identified, right? So this question is type of a general solution, but then the way it works is that we need to take the denominator of each fraction there, and then we need to apply a general solution on that, right? Now how do we do this? So the first thing that we do is we say sine 2 alpha minus sine alpha needs to be equals to 0, right, in order for this to be undefined, because this is a fraction, right? A fraction we know that it is undefined if the denominator is 0. So here they're asking for which values of alpha, right, is the identity undefined, is the identity undefined. So this then means now what we need to do is we need to say sine 2 alpha minus sine alpha is equals to 0. So that was from the first fraction, or the second fraction, sine alpha equals to 0. Then from here we're going to apply general solution on these two, right? Now here I'm going to start with the first one, right? So I'm going to start with this one, sine 2 alpha minus sine alpha equals to 0. So this is going to be 2 sine alpha times cos alpha minus sine alpha equals to 0, and then I'll take out the sine alpha and then I have 2 cos alpha minus 1 equals to 0. And then here I can see that sine alpha is 0, or 2 cos alpha is 1, which means cos alpha is equals to positive 1 over 2, right? And now here I can see I have 2 types of general solution, and I also had that third one there, right? Just to put it there. So as you can see, it's the same as this one, so I won't have to write it over and over again. Right, so what I'm going to do is, first things first, we're going to take the first take, which is cos alpha is equals to positive 1 over 2. So let's do a general solution here. So the first thing that we do is, we know that this part, the sign here tells us in which quadrant is cos positive, right? So cos is positive in first quadrant and fourth quadrant, and then from there we then need to find our reference angle. So our reference angle is going to be cos inverse 1 over 2. Press that in your calculator, 1 over 2, so this is going to be 60. And then from there we're going to do our general solution. Now the formula for general solution, before I go there, this angle, whatever angle is there, this is what we want to find. So this is what you call a general solution, right? Now the general formula for this is that general solution is equals to, right, a reduction in whatever quadrant we're going to be talking about, plus the period of the trig ratio we're going to be working with times k, and then we're going to say where k is an element of integers, right? Now that is the basic formula for all type of general solutions, right? Now here, our general solution, for example, first things first is, we know that we're working with quadrant 1. Then quadrant 1 has a reduction here that is reference angle. So we're not using 360 plus theta, right? We're using theta. So theta is taken as reference angle because the angle there in reference angle is always between 0 and 90. As you can see here, this is an angle. The reference angle here, it is between 0 and 90. All right, then our first quadrant is that. Fourth quadrant will be 360 minus reference angle. So this would then mean now that the general solution for the first quadrant will be our general solution, which is alpha. So will be alpha equals to reference angle 60 plus, now the period for cos is 360, so 360k, where k is an element of integers. And then now here we got our general solution. Then we're going to do the second one. So the second one will be alpha is equals to 360 minus 60 plus 360k, where k is an element of integers. So this will mean alpha is 60 plus 360k, where like that. And then here alpha is going to be 300 plus 360k. So that's the first one, right? Then now the second one is where we have sine alpha equals to 0. Now here this is neutral. So because of this is neutral, it means we can look at any quadrant, right? So I can just look at quadrant 1 and quadrant 2. It won't matter, right? So here we then say our reference angle is equals to sine inverse of 0. So that is 0. And then now our first quadrant, now it's reference angle, and then our second quadrant, it is 180 minus theta, hence 180 minus reference angle. And then this will mean now general solution alpha is going to be 0 plus period for sine is 360k, where k is an element of integers. And then here alpha is going to be 180 minus 0 plus 360k, where k is an element of integers. And then this is going to be 0 plus 360k, whereas this one is 180 plus 360k. And that is going to be the end of this video. So if you like the video, please make sure that you send a comment. Let me know how you think about this video, and please subscribe so that you will be able to get another video when I get it uploaded. Until next time guys, stay blessed by the best. I'm gonna see you on to the next one. Cheers.